Hi, everybody. We're here to talk about solutions. And so we want to start off with some key definitions. Our first one is soluble. That means it is capable of being dissolved. So sugar is soluble. Salt is soluble. These are things that will dissolve. A solution is a homogeneous mixture. Homo means the same, so when we say a homogeneous mixture, we're talking about a mixture that looks the same throughout. Saturated is exactly the maximum amount of dissolved solute for a particular solvent. So this is the most under normal situation that it could possibly dissolve. So if I'm dissolving salt, there is a point where it doesn't want to dissolve any more salt. That point where it has dissolved everything it can, we call it saturated. Unsaturated would be less solute than the maximum amount of the solute. And we find that it would be under the curve when we start working with the solution curves. But the idea here is that if we added more, we could dissolve more in there because it's not totally full. It's not saturated. And supersaturated. So there are situations where more dissolved solute than the maximum can be present, but this is something that has to be very specifically made, and it is going to be unstable. It doesn't take but one little teeny tiny particle of the soluble substance, and everything that was extra can fall out. And so you'll all of a sudden see this mass come out. So supersaturated, we put more in, but we have to do it a special way. We have to make this happen. It won't happen naturally. So when we're talking about a solution, we have two key parts. We have the solute, that's the part that gets dissolved, like the sugar, and the solvent, which is the part in which the dissolving happens. And if you remember from our water properties lecture, that the water is the universal solvent. So a lot of things will dissolve in water. So what happens is the solute enters the system, the solvent, and it ultimately will spread evenly out. So remember, solute is the thing that can be dissolved, and solvent is the thing that does the dissolving. Three factors that increase rate of dissolving, how fast dissolving happens for solids in a liquid solvent. So like we're adding salt to water. We've actually talked about our rates to speed up a reaction, or same basic concept here from that previous unit. So the surface area, if we increase the surface area, it increases the rate of dissolving. We can do this by breaking it or grinding it up. Think of a sugar cube versus granulated sugar. Granulated sugar has more surface area, dissolves faster. Agitation. If you shake or stir this solution, it will increase the rate of dissolving because we're moving those particles around and coming in better contact. And then heat. If you increase temperature, usually it will increase the rate of dissolving. We also have two factors that will increase the rate of dissolving for a gas in a liquid. So like our soft drinks. Temperature, increase the temperature and we will usually decrease the rate of dissolving. So if you're trying to dissolve gas in a liquid, you want to make it cooler. That's why we like to cool our soft drinks. And pressure, if you increase the pressure, you increase the rate of dissolving. That's why when we have a soft drink, when we open that bottle, especially that first time, you get that fizz as all of the gas starts popping out of solution because it had been under pressure. It has little to no effect on the dissolving rate of a solid, so that's why we didn't mention pressure on the previous list. But when it comes to a gas, it really does play a big role. Factors affecting solubility. So these are things that will affect how much will actually dissolve. So the type of solvent and solutes you're dealing with, in general, like dissolves like. So a polar solvent like water will dissolve polar and ionic solutes because both of those will have charges. Nonpolar solvents like oils are typically going to dissolve nonpolar solutes, those without charges. Pressure, liquids and solids, there's little to no effect, but with gases, the solubility will increase with increased pressure. And then temperature, liquids and solids, if we increase the temperature, we increase the solubility for the most part. And for gases, if we increase the temperature, we decrease the solubility. So remember, with solids, when we make it warmer, we can typically dissolve more. But with gases, we want to decrease the temperature to get more in there. Some solutions will conduct electricity, some don't. We already know this. We've talked about it before. We consider these concepts electrolytes. So electrolytes are compounds that conduct an electric current in an aqueous solution or the molten state. So when they are in a liquid format, whether they're dissolved in some sort of water or something, or they are just melted. If they conduct electricity, we consider them electrolytes. An electrolyte solution has charged particles, so it has ions. Ions can move, so any salt that's dissolved in water would be considered an electrolyte. Sodium chloride, potassium iodide, all of the different salts. We can have strong electrolytes. So in a large portion of the solution, we're going to have ions kind of throughout. So most of the aqueous solutions of ionic compounds are going to be strong electrolytes. When we're talking about a weak electrolyte, only a small part of the solute has ions. So we're not breaking all of it into ions, charged particles. We're just breaking a small part. So our weak acids and bases would do this. Non-electrolytes are compounds that do not conduct electricity, whether they're aqueous or melted or anything like that. So they are not going to conduct, they are non-electrolytes. Things like distilled water, gases, non-polar covalent compounds when we put two nonmetals together, and a lot of the organic compounds like alcohols, sugars, things like that, they're going to have those carbon atom bases. So with an electrolyte solution, we're breaking it into charged particles. We're going to have ions, whether it's a lot of ions, which would be strong, or just some of its ions, that would be weak. And a non-electrolyte, notice that we can dissolve, but they're not breaking into charged particles. Difference between salt and sugar. We dissolve them both, but one makes charged particles and one does not. So here we want you to practice identifying the solute and the solvent. So we have 10 grams of sugar and 40 grams of water. Which one is being dissolved? Which one is doing the dissolving? So the solute, what is being dissolved, would be sugar, and the solvent, what is doing the dissolving, is water. Our other option, we have 75 grams of potassium bromide, and we have 100 grams of water. Which one is being dissolved? Which one is doing the dissolving? So the solute is potassium bromide, the solvent is water. In both of these examples, remember water is the universal solvent, so a lot of times water is the solvent. Just reiterating to make sure you understand, saturated solution, the maximum amount of solute that is soluble at that temperature, the most it can hold. Unsaturated, it's going to have less than the maximum for that temperature. That means we could put more, dissolve more into it. And supersaturated, remember these don't occur naturally, we have to make them, contain more than the maximum dissolved for that temperature. So we've actually put more into the solution, dissolved into the solution, than it really should be able to hold. So if we look at a solubility curve such as this one, you'll notice we have 3 different substances shown on this graph. We have KNO3, KCl, and NaCl. Okay, so I want to start with 50 grams of KCl. So KCl, 50 grams, so I come over here to grams, and here's my 50. And I take it all the way over till I hit the line, KCl, and that is at 80 degrees. So, if I have 50 grams dissolved at 90 degrees, we can hold more than 50. So obviously our point is below. That makes it U, or unsaturated. B, we have 50 grams of KCl in 100 grams at 60 degrees. So at 60 degrees, my KCl, notice that 50 is above the line. So that would be supersaturated. That's why we put an SS. If we have 50 grams of KNO3 dissolved in 50 grams of water at 60 degrees Celsius, here's 60, and notice it hits this line at 100. But here's the problem. If you look at the side of the graph here, it says grams solute dissolved in 100 grams of water. Well, we're saying we only have 50 grams of water. So if we have 50 grams in 50 grams of water, that would be the same as 100 grams in 100 grams of water. So at 60 degrees, that's at 100, but we only have 50 in 50, so we know that that would be the same as hitting that line point, so it's going to be saturated. So that's a little more challenging when you have to stop and convert, because this water measurement that we're talking about is different. We had to do some conversion for that. So solution concentration, some general terms. You hear these a lot. These are terms you're probably familiar with. We have dilute, so a solution that contains relatively small amounts of the dissolved solute. So maybe we only put a pinch of salt in the water. That might be dilute. Whereas if we put 3 tablespoons of salt in the water to dissolve, that would be concentrated. So it's a solution that contains a relatively large amount of dissolved solute.